Okay, so for number 5 in chapter 3, section 8, we're given the equation f of x equals x cubed plus x minus 1. Okay? Sorry, that looks really bad. Okay, so x cubed plus x minus 1. And it says to approximate the zeros of the function, use Newton's method and continue the process until two successive approximations differ by less than 0.001. So we're trying to get to a goal of 0.001 apart. Less than that. Then find the zeros. Okay. And so we're going to find f prime of x, which would be 3x squared plus 1. And then we can make our chart. So we have x to the n, then f of x, f prime of x, and then x to the n minus f of x over f prime of x. And it doesn't give us an initial guess, so I'm just going to do 0. And if you plug 0 into f of x, you're going to get negative 1. If you plug it into the derivative, you would get 1. And 0 minus negative 1 over 1 would be 0 minus negative 1, which becomes 0 plus 1, so it becomes 1. And then from here, we'll plug 1 in here. And so when you plug 1 into f of x, you'd get 1 plus 1 minus 1, so 2 minus 1, which is 1. When you plug 1 into here, you would get 3 plus 1, which is 4. And 1 minus 1/4, 0.75, or, 3/4. Okay. So after this, we're probably going to have to start using a calculator. So I have mine out over there. And so we're going to plug in 0.75 now into f of x. So it'll be 0.75 cubed plus 0.75 minus 1, which is, my calculator says it's 171875. That's what my calculator says. So I'm going to save that as f, so I know. And then when we plug it into f prime, it's going to be 3 times 0.75 squared plus 1, which is 2.6875. And I'm going to control store that as, I'll say FF. Okay, and so then when I do 0.75 minus the 0.171875 divided by the 2.6875, I get 0.686, sorry, I can't read it, 047. So I'm going to plug that back in over here, and I'm going to actually control store that as x, so I can just type in x now. And so I'm going to do x cubed plus x minus 1. And I get 0.008941. 8941. Okay, I'll control store that. So I have it, and then I'm going to say 3x squared plus 1. And that's 2.41198. So 2.41198. I'll control store that too. And so then I get x minus a divided by b. And you get 0.68234. 0.68234. And I think I still need to go another one because that's a pretty big gap. And it asks for 0.001, 0.001. Yeah, they're not 0.001 apart. So now I'm going to plug in 0.68234 in. I'm going to store that, so I can just plug that in. And so I'm going to do that answer cubed plus itself minus 1 is going to be 0.000028. I think that's 4 zeros. Yep. 2/8. And I'll control store that. And then I'm going to take the derivative. Plus 1. And I get 2.39676. Okay, so 2.39676. Okay, I'm going to control store that. And then I will take the 0.68234 minus 0.00028 divided by 2.39676. And I get 0.682328. Okay, so 0.00. Okay, so those differ by a lot. I think that is a good stopping point. Those numbers are almost exactly the same. And so my answer here, my x is 0. Oops, sorry, I wrote that the wrong way. It's supposed to be 682, not 628. Can't even read that. Okay. So answer would be 0.682, and that is what x equals. And that is what it is asking for. And then it says find the zeros using a graphing calculator and compare the results. And so I will check it on my calculator. I'll graph them. X cubed plus x minus 1. Oh, I did it the wrong way. X cubed. Okay, and I get that on my graphing calculator. And so if I analyze that and go to 0, and I see that that's my point. You can't really read it, but it says 0.682. And that's what I got.